Today I'm going to be talking about the addition and subtraction of vectors. The first method that we're going to be talking about is the triangle law of addition. So we have two vectors, A and B, and they're going to be arranged head to tail. The sum, A plus B, is the vector from the tail of A to the head of B. So I'm going to draw two vectors here. So I will start with vector A, and then they need to be arranged head to tail, so I will draw vector B. Now it says that vector A plus B is the vector from the tail of A to the head of B. So this is my vector A plus B. Alright, so in this next example, it says, given the vectors shown below, add vector A plus vector B plus vector C plus vector D. I'm going to try my best to keep the same colors here, make it a little bit easier for you. So first thing, I'm going to redraw vector A. Next, remember I must go tip to tail. I'm going to add vector B. And again, tip to tail, I'm going to add vector C. And then finally, again, tip to tail, I'm going to add vector D, which is in this direction. So the resulting vector is the vector from the tail of A to the tip of my last vector, which is D. So this vector right here is vector A plus B plus C plus D. Now another way that I can think about this, I can say, let's call this point A, B, C, D, and E. So if I wanted to do this algebraically, I could say that this resulting vector, instead of labeling it A plus B plus C plus D, is the vector AE. And on the next page, I'm going to show you what I mean by that. So what you see here is just the vectors added together again. I don't have the resultant drawn in here. So if I want to add A plus B plus C plus D, what I'm going to do is I'm going to rewrite them using these letters. So vector A is AB, and vector B is BC, and vector C is CD, and vector D is DE. Now, what I know, and I'm just going to use, I guess I'll use black here. If I have just vector AB plus BC, that would give me this resultant right here. And if I look, that would be vector AC. So essentially what we're doing is we're canceling out these B's because we're going to be and then starting right from point B again. Now I'm going to continue writing, plus vector CD plus vector DE. Now if I wanted to continue, I could see that if I consolidated these next two vectors here, again, I have these two capital C's on the inside, so AC plus CD is just the vector AD plus DE. And then again, when I add these two, I have two capital D's on the inside, so AD plus DE is just vector AE. Now eventually, many of you are going to be able to go right from this first line to the last line. I'm not necessarily saying that you need to show me all of these steps in between if you don't have to. In this next example, it asks you to determine the vector equal to each sum. So again, I can see here that I have AB plus BC. That's going to leave me with vector AC plus CF, which is equal to vector AF. Now in this next example, or part B, it doesn't look as easy as part A. And the reason for this is because it says AE plus BD. So right away I can tell that I don't have things canceling out the exact same way as I'm used to. What I can do is I can do a little bit of rearranging. So I'm going to start with AE. And I can look for another vector, and it looks like this one would be a good choice. Vector EB. And then I can continue on. So BD would be another good choice. Cancel those B's out. And then finally DC. So if I go through here, I've got AE and EB. We know that that is just vector AB. And I'm going to show all of this work. And again, a lot of you are going to get to that point where you won't need to show me all of these steps. AB plus BD is vector AD. And then finally, AD plus DC is vector AC. Okay, so the second method that we're going to be talking about is the parallelogram law of addition. Say we have two vectors, vector C and vector D, being any two vectors tail to tail. This is the big difference here. So first method is tip to tail or head to tail, and method 2 is tail to tail. Complete the parallelogram. So I'm going to have vector C right here, and I'm going to have vector D right here. And it says that I need to complete this parallelogram. So I've got this right here. Now it says that the sum C plus D is the vector with the same tail as C and D, with its head at the opposite vertex of the parallelogram. So this is vector C plus D. Now, we can use method 1, so if I'm going to show you the exact same way as method 1, we would have vector C, and we would have to shift vector D so that it would be tip to tail, and then we can see that vector C plus D is the exact same no matter which method we use. All right, so in this example, we have a boat with forward velocity in still water, and its velocity is 24 meters per second. It's going to be traveling across a river directly towards the opposite shore. So I have this boat, and it is traveling across a river with a forward velocity of 24 meters per second. At the same time, the current at 6 meters per second carries the boat down the river. So at the exact same time, I have this current going 6 meters per second. Determine the resultant velocity of the boat. So I'm going to use method 1. If you want to do this on your own and use method 2, you will get the exact same results. So the first thing that I'm going to draw is the 24 meters per second, so the velocity of the boat. And then at the exact same time, we have the current at 6 meters per second. So if I'm going to draw in my velocity, or my resultant here, again, I have these rearranged tip to tail. I'm using method 1. My resultant is going to go like this, and I'm going to label this as the magnitude of R, or my resultant. And what you're going to notice is that since my boat is traveling directly across a river, and the current is flowing at a 90-degree angle, I do have this 90 here as well. So because I have a right angle, I am able to use Pythagorean theorem to find my resultant vector. So the magnitude of R squared is going to be equal to 24 squared plus 6 squared. So the magnitude of R squared is equal to 612. So I've skipped a couple of steps in here. 24 squared plus 6 squared is 612. And then we know that if I take the square root of both of those sides, I'm going to get the magnitude of r is equal to 24.7 meters per second. So now that I have my resultant, I can figure out a direction or an angle. So if I'm looking in this diagram right here, I have my 6 meters per second. This is my current, and we know that this is running parallel to the river. So it is running parallel to the shore. So if I'm able to find this angle right here, I would be able to give the direction relative to the shore. So if I'm looking for this angle, I know it's a 90-degree triangle. I am able to use my primary trig ratios. So I would have tan of theta is equal to opposite over adjacent. So tan of theta is equal to 24 over 6. And then I would get theta is equal to tan inverse of 24 over 6. Theta is equal to approximately 76 degrees. And therefore, I would be able to say that my resultant is equal to 24.7 meters per second at an angle of approximately 76 degrees relative to the shore. Sorry, I'm having to squeeze that in there.